right. Okay. So there is 11.1. This will be an easy section. I think we can get it done in 35 minutes here. All right, so how do you handle two equations at the same time? Remember this from algebra? This is kind of like a little review from algebra. How do you handle two equations at the same time? Remember how you add them up so that something cancels out? Do you remember that kind of thing? So to handle these two equations at the same time, we add them up, and when you add them up, 1x and 1x is 2x. 1y and minus 1y cancels. 8 and 2 is 10. Remember all that from your algebra days? Called the elimination method. When you add them up, the y's eliminate. Like that. And then how do you finish solving for x? Now that we have just x and no y, we can finish by just dividing both sides by 2. Bless you. X is 5, so we've got x. And now how do we get y? Plug it in. Yeah, bring it over. I'll just bring it over here. Plug in x is 5. I'm going to grab you can grab the first equation or the second. Doesn't really matter. X plus y is 8. Put in the 5. 5 plus y is 8. Subtract 5 from both sides. Y is 3. So there we go. Got the answers for x and for y. Is that good? Remember all that? I'm assuming I can go fast because it's from algebra. Come see me if that's... Okay, so let's try that one. So 2x equals 12 and x plus 2y equals 0. Can you solve for x and y in those two equations? Remember how that works? So I'll give you a second there. So the top one is 2x is 12. The bottom one is x plus 2y is 0. So try that one. So solve for x and y. Give you just a second. I think you'll get more out of it that way, rather than me just crank it out. So what can you do with that top equation right away? We can solve that one. So this one I'm not going to do like the last one, because this one's kind of different, huh? It's like ready to go. So 2x is 12. What do we do to solve there for x? Just divide by that 2, huh? So x is 6. So this is different than the last one. On the last one I added them up. This one, just x is just ready to go. Because you see that top equation doesn't have a y. So maybe I could summarize it this way. Basically, you need to get an equation that only has one letter. That's what I did with this last one. By adding the two equations and getting the y's to cancel, I got only x, huh? And that's the deal. You got to get down to one letter. We can't really handle two letters at the same time. You got to get one of the letters to go away. Well, this one, this problem number 2 here, they already gave us an equation that only has one letter, so that's nice. So we just solve for x. X is 6, and then what do? Plug it in. Plug it into the second one, huh? So I just go, okay, plug it in right there. So it's 6 plus 2y is 0. Now I can solve, plug that in for x. Now I can solve for y. Jump the 6 to the other side. 2y is minus 6. Divide by 2. Y is minus 3. There we go. Good on that. I'm going to keep moving. So I'm going to make sure I... Okay, so bring it up here. 2x plus y is 9. And 10x plus 5y is 14. All right, so I'll give you a second. So go ahead. So now on this one, oh, by the way, I can't just add these. Huh? You probably know that. You remember that from algebra? Remember, like, don't write this down. This won't work. If I was to add these right now, what would I get? 2x and 10x would be 12x. 1y and 5y would be 6y. 9 and 14, what is that? 23. That didn't work. Now, what do I mean didn't work? I added them and everything. What's the problem I'm having? Why don't I like that? Why did that not work?
Because you didn't get rid of neither the x nor the y.
Right, you need one of the letters to cancel out, huh? Remember, we're trying to get down to just one letter. We don't want x and y both there, because we can't handle both letters. We need to get down to one letter. Well, it didn't work this time. Nothing canceled out when I added them. So that's a bummer. So why not? Why didn't anything cancel out? It worked great over here when I added them up right there. See how those y's canceled out, and I got down to just x, you know? And that was easy then. Once you had only one letter, then you could solve it. So what's the difference? What happened here that when I added them, stuff canceled? The y's were opposites, weren't they? We had a plus 1y and a minus 1y. Whereas right here, the y's are not opposites. I got a plus 1y and a plus 5. That's not going to work. So you've got to make them opposites before you add. You remember this from algebra? You got to make them opposites before you add. That number 1 was just artificially nice and easy. They were already opposites. That'll never happen again. So now you have to make them opposites. So what do I got to do to that plus 1y to make it the opposite of plus 5y? Multiply by negative 5, huh? Yeah, I'm going to multiply that top equation by negative 5. Everybody good with that? Because that'll make that negative 5y, which will be the opposite of positive 5y. I'm not going to mess with the second equation at all. So here we go. Here's the first equation. It'll become negative 10x minus 5y minus 45. I multiplied negative 5 all the way across. You can always do the same thing to both sides of an equation. The second equation, I'll just bring it down. No changes at all. Just to kind of keep things lined up. Okay, and now I'm going to add them up. So when you add them up, look what happens. X's and Y's cancel, don't they? And over here, I don't know, what is that? Minus something, 31. So what's up with that? I tried to cancel out Y, but X also cancel. What does that mean?
No solution.
Yeah, that means, yeah, when you get like 0 plus 0 equals a number that's not 0, that means no solution. So you check the no solution box. That means there's no answer to those two equations. There's no answer that makes both equations true at the same time. There's all kinds of answers that make just one of them true. Like you could put in 4 for x and 1 for y. That makes the top one true. 2 times 4 is 8 plus 1 is 9. But that doesn't make the bottom one true. 10 times 4 plus 5 times 1 is certainly not 14. It's 45. So you see how there's no xy that makes both true at the same time. That's what that means. Hey, do you remember from algebra? What does that mean about the graph? These are both lines, aren't they? They're just x and y to the first power. So if I graphed them, they'd both be lines. And what would we see on the graph of the two lines when we get no solution? What does that mean about those two lines? Yeah, what kind of lines are they? Algebra, assumed prerequisite for this course. Do you remember? Parallel lines, yeah. Remember that from your algebra days? No, not so much? There are two parallel lines that don't intersect. That's why there's no crossing, there's no solution. That's what that means. If you were to bother, we're not going to graph them and everything, but just letting you know, that's what it means when there's no solution. There's two lines that don't touch. They're parallel. This one, okay. So there you go. Try that one. 2x minus 2y is minus 2. 5x plus y is 13. All right, so try that. You can make the two x's opposites or the two y's. It doesn't really matter. Pick whichever you prefer. Just so that we're all on the same page, why don't we all just agree to do the y's? So let's make these two y's become opposites so that when we add them, the y's will cancel out. So how would I make those two y's become opposites? What do I got to multiply to which equation?
Multiply the bottom by 2.
Yeah, bottom by positive 2. Does everybody see that? So if you multiply the bottom equation by positive 2, that'll make that a plus 2y. That's the opposite of the minus 2y. Then you add them up, they'll cancel. So go ahead, try that. I'll give you just a second. I think you'll get more out of it rather than just watching me do it. So crank that out, and then you should be able to get answer for one letter, and then plug in to get the other one. Give you just a second. We're doing okay, and so then let's see. I'll bring down that top equation with no changes at all. That'll be what, 2x minus 2y is minus 2, and then the bottom equation becomes, what's that? 10x plus 2y is 26, and then add those up. 12x, these guys cancel. What's that? 24. Is that good? Did y'all get to there okay? And then just divide by that 12. And x is 2. So we got x. X is 2. And now, once you get your first answer, just plug it in. You can plug it in anywhere. Doesn't really matter. Just plug in any of those, literally any of those 4 equations, and you'll get the other letter. So we've got x. We got x is 2. I'm kind of going to go to a fresh screen if that's okay. It's kind of messy there. There's just words everywhere. So, that okay? So number 4. And I'll grab the top equation. Was it 2x minus 2y is minus 2? Everybody got that copy down okay? So x is 2, going to plug in x is 2. So let's do that. The first chance, plug that in. So we get 2 times 2 minus 2y is minus 2. 4 minus 2y is minus 2. Got to solve. Here's the wall. Solve for y. Subtract 4 from both sides. Those cancel. Minus 2y is minus 6. Divide by minus 2. Y is 3. So we got y is 3. X is 2. That good? Is it kind of coming back a little bit? How those work out? Anything I can say to help on that? That okay? On that? When we go back to that first page, anything there? Is that okay? So we just multiplied that bottom equation by 2. That made the y's opposites, huh? It's all about opposites. That way they eliminate. That's why it's called the elimination method when you add them up. They eliminate. So it's all about getting down to one letter, huh? All about getting down to one letter, then you can solve. All right. And there's that second. Maybe we better do this one since it's got fractions, which are always kind of a pain. Okay. In fact, I'm just going to rewrite it because I need more room. So number 5 is 2x plus 5y is 12. 2x plus 5y is 12. And the other one is x minus y is 5 halves. X minus y is 5 halves. Yeah. What should we do? Yeah. Probably if they give fractions like this, I just like to get rid of them right away. So why don't we do that? So what would I do? Not trying to cancel anything right now, but just trying to get rid of the fractions. What would I do to get rid of those fractions? Yeah, we can multiply. Yeah, and we can make the x's opposites, couldn't we? Could you make those x's opposites? This is 2x. Now you could do the y's. Well, here. Let me do 2 different things. You could do it all at once, but I'm going to do it slow. So I multiplied through by 2 there. Why? Trying to cancel that out. You know what I mean? Because I don't want fractions. Fractions are a pain. So I'm going to rewrite both equations. I'll bring the top one down. The top one has not changed. I kind of bring them both down together just to keep things lined up. This is 2x minus 2y is 5. Does that make sense what I did? All I did so far is I just got rid of the fraction. So whenever they give you fractions, you know what to do, huh? Just multiply through by that denominator and it just cancels out. Now, are they ready to be added right now, or do we need to do something to them to help with that?
Do something.
Yeah, what, I got to make opposites, huh? Got to make opposites on that. So I could make those two x's become opposites, right? If I multiplied through that bottom equation by -1, how about I just do that? Just go -1, -1, -1 on that bottom equation. That'll or the top one. It doesn't really matter. Just make one of those two x's -2x. Is that good? Then it'll be opposites. So what do we got? 2x plus 5y is 12. Minus 2x plus 2y is minus 5. Add these up. X's cancel. 7y is 7. Divide by 7. Y is 1. So we got y equals 1. Let's go get x. So plug in. Where do you plug in? Anywhere you want. Literally, you can plug into any of those equations. They all would work. It doesn't really matter. So I always just grab the first one usually. 2x plus 5y is 12. Plug in the 1. 2x plus 5 times 1 is 12. 2x plus 5 is 12. Subtract 5. 2x is 7. Divide by 2. There it is. We got x, we got y. Good? Not too bad? Kind of remember that now? Okay, because we're going to go to 3 by 3s now. 3 letters, 3 equations. Yeah, those are 0. Those gap pieces. Yeah. So, actually, I'm going to rewrite it because there's just not room for that there. So, number 7 is x minus y equals 2. 2, and 5x minus 7y is 20. Oh, wait, 7z, right? Yeah, 7z is 20. And 5y plus z is 10. Is that right? Yeah. Okay. So there we go. So now we have, this is called a 3 by 3, 3 equations, 3 letters, 3 by 3. So how do you solve a 3 by 3? Well, you need to kind of break it down to be a 2 by 2. That's kind of the plan. We don't really, it's like reduction. You want to get rid of one of the letters. It doesn't really matter which one. But if you could just get rid of, like, say, x, if you could somehow just get rid of all these x's, then do you see what you would have? You would have just 2 letters, and that we can handle. We can handle 2 letters. We learned how to do that, right? This problem was 2 letters right here. We solved it. So somehow we've got to get rid of, say, all the x's. It doesn't have to be x. You can pick the y's or the z's or whatever. But you got to get rid of one of the letters. Let me put that back the way it was. Is that what it was? Yeah. Anyway, so let's get rid of x. So that's the first step. First, get rid of x from all. Get rid of x from all the equations. So, exactly, that little ding is perfect emphasis. All right, get rid of x from all the equations. So how do you get rid of x from all the equations? What could I do? I can just make these guys be opposites, right? So just multiply that top one by -5. Does that make sense? Make those opposites. That's exactly what I'll do. So -5, -5, -5. And what do we get? -5x plus 5y, -10. And I'm going to rewrite the second equation right below it. Like that. And then just going to add those 2 up, and the 5 x's cancel, and we get 5y minus 7z. 20 minus 10 is 10, huh? Let me stop right there. Everybody good so far? Everybody see what I did? So I just, is that confusing how you know what? I mean, it's true and everything, but I might have confused you. Let me let me erase what I just did and redo it. Let me move it over. I think that I could see where that would look confusing. Let me move it over a little bit. See if that's more helpful. So what if I? So really, let me just take it over here and over here, because that's what's happening. That's more helpful. Plus 5y, -10. and then this one goes over here, 5x minus 7z is 20, and I added them up, 5y minus 7z is 10. So that's what I did. I took the first and the second equations, and I got the x's to cancel, right? So now, do y'all see what we've got? We got this one, which has no x, and then the one we've had from the beginning, equation number 3, which has no x. So now I can put those two together. 5y plus z is 10, and this one, 5y minus 7z is 10. And now I've got two equations with two letters. Is that making sense there? So that should be a little bit easier, just two equations with two letters. So how do you solve two equations with two letters? Now that we got rid of x. So everybody see the game plan. First, get rid of x from all. So I did it. I got rid of x. You know, the bottom. What was nice is that the bottom one never had x. So I didn't have to mess with him at all. So we've got rid of x from all the equations. And now we just have two equations with y and z. You know what to do now. What can I get to? How can I make somebody opposites there? What am I going to do? Yeah, -1, huh? Yeah, you can do the top equation or the bottom. It doesn't really matter. I'll just, maybe I'll just do this top equation. Multiply through by -1. That'll become minus 5y minus z minus 10. And then the bottom one will still just be as it was. 5y minus 7z is 10. Add them up. These cancel. Minus 8z minus 1z minus 7z is minus 8z. And this is 0, huh? Like that. Solve for z. Divide by minus 8. Z is 0. So we got an answer for z. We got z as 0, and you know what we're going to do now. We're going to plug in, but you got to be a little careful where you plug in on these three-letter ones. You don't want to plug. You want to plug in somewhere where it's only z and one other letter. That way you can solve for the other letter, right? You know what I mean? So anywhere where plug in. Let me write a little note on that. Plug in z equals 0 anywhere with z and one other letter. That's what you want to do. Anywhere that you got z and just one other letter. So where do we have z and just one other letter? Well, like right here, for example. Bring that on down. We got 5y plus z is 10. Put in the 0 right there. So 5y plus 0 is 10. 5y is 10 divided by 5. So y is 2. Can you read all that? Y is 2. Is that good? Could have plugged into the middle equation. That would have worked also. So I've got z is 0, y is 2, and now plug into some other equation that's got x, because we just got to get x now. We got y, we got z, so I'm going to go to fresh screen. Maybe use the top one. What was the original? X minus y equals 2. So x minus y is 2. Is that what it was? Yeah, 2. This is the finish of number 7 here. And I've got z is 0, y is 2. So z is 0, y is 2. So plug in that 2 there. X minus 2 is 2. Add 2 to both sides. X is 4. There we go. So we got all three answers. X is 4, y is 2, z is 0. Questions on that one? How could you check to make sure your answer is right?
Plug it in.
Yeah, you could, 4, 2, 0. You could go back and back to, bless you.
Thank you.
And back to the original. If you plug in 4, what was it? 4, 2, 0. 4 and 2, 4 and 0. 4, 2, and 0. They should all be true. Anyway, I don't got time for that. Questions on that? That one good? So, you know, on this one, I would get those z's to drop out first. See how easy it is to get the z's to drop out? So I just wanted to point out again, you don't have to start with x. Do whatever's easiest. I would just add these first two equations. I would just take x minus y minus z equals 2, 5x plus 3y plus z equals 2. And I would add those up. And I'd get what? 6x plus 2y, right? 3 minus 1. Z's cancel, and that's a 4 over there. So you see how I would get z to drop out of those first two? And then I've got that other equation that never had z, that second one, which is 30x plus 10y is 0. Oh, something bad's going to happen here. Oh, is that going to be no solution? Yeah. Is that true? Yeah, this is a no solution. Yeah, because now, everybody good so far? Now if you, how do you make these x's be opposites? Well, you can make that one negative 30, huh? Multiply by negative 5. Negative 5 times 6 be negative 30. And both x and y are going to cancel out. I didn't realize. So if you multiply through this equation by negative 5, you're going to get negative 30x, negative 10y, negative 20. The bottom equation, still just bring it down, 30x plus 10y. Yeah, it's going to be no 0, 0, 0, 0, negative 20. That's another no solution. All right, well, I wasn't going to do that problem, but there it is. It's a no solution. So, do you see how I eliminated z? Just do whatever's easiest, you know. You got to get one of the letters to drop out, though, huh? So, either x or y or z, whatever. Get something to drop out. Is that good? So you take two equations and get one of the letters to drop out. The other one already had that letter dropped out. Then it was easy from there. Questions on that? That okay? But I'll come back to 9 and 10. I guess I'm not going to finish today. All right. Perimeter of a rectangle. If you have a rectangle that has width and length, what's the perimeter formula for a rectangle? Yeah, exactly. 2 times length plus 2 times width, huh? A rectangle has got a length, a width, a length, and another width, huh? Like perimeter just means around the outer edge, so 2 lengths and 2 widths added up. So they're saying the perimeter is 200. So I can plug in 200 for the perimeter. And it's 2L plus 2W. And the length is L equals, is equals, huh? 4 times the width. See that other formula they're giving me up there? L is equals 4 times width. So now, so what that means is again, I have two equations, this one and this one, that have 2 letters, L and W. Instead of X and Y, it's L and W. So it's the same kind of game as this section. That's what this chapter is all about, is multi-letters. So 2 equations with 2 letters, L and W. So how should I solve for both letters?
So can you just do 200 equals 2 times 4w?
Yeah. So substitution's a good idea on this one, huh? Totally good idea. Yeah, just grab that 4w, plug it in right there for L, huh? Because that's what it means when L is 4w. You can put in 4w, as you know. Exactly. 2 times 4w plus 2w. Is that good? So that way you get, again, it's all about getting it down to one letter, huh? Just now we can do it. It's got only one letter. So 200, what is that? 8w and 2w. And so that's 10w divided by 10. W is 20. And once you get that, then you plug it in right there. L is 4 times 20. L is 80. The width is 20, the length is 80. All right, you guys are thinking, Mr. Chair, and that's all.